Hello friends, I am MB and I am discussing some mathematical expressions. So today I am going to discuss functions. So how to write some functions as a whenever I use a Sympy, this is the part library inside with Python. So let's see the Sympy object, the represent of functions. It can be created with the Sympy dot functions. So if I write just if you write x as a, another is the y, and third is the z. Now all will equal to Sympy, because I have already imported the Sympy. So Sympy dot function symbol. So if you write the symbols, Sympy dot is symbols. Yeah, look here. If you write a single symbol, then you can write the capital SYMBOL, and I am going to write here multiple symbols, so you need to write a small s and YMBOLS. So x comma y comma z, and I am going to write here the f. F means just look like a, it can look like a code listing where we create an undefined functions f, so which we apply to the symbols x and another functions look like a g and others. So first I am going to write here f as a variable and will equal to Sympy dot, and I am going to write capital F UNCTION, and now write here small functions and going to type f. Let's see, type parenthesis and f. Okay, now we can see here, yeah. So Sympy dot code dot functions dot undefined functions, undefined function. So if I write here fx, so fx it can represent here, just if I write f comma x, so fx means your output as look like a same functions, x means fx. Now I am going to print here another functions look like a create a new variable look like a g will equal to Sympy dot function and parenthesis. First I write here the g and the another parenthesis look like a x comma y comma z, x comma y comma z. Now let's see the print here g. So g will create like a g functions, yeah, g functions contains here x, y and z. So this is a way we can create another functions. And if you write here just if you write here g dot free, because I have created here, so g dot free underscore symbol, free underscore symbol. This means without symbol it like this. So look like this, x, y and z. So we use a property free dot symbols which return a set of unique symbols contained in a given expression. So in this case, the applied undefined functions g. So this will be important after some time. You can see like whenever we consider like derivatives of the abstract functions. So we will see how to create. So keep your mind. Another important applications to undefined functions is for specifying a differential equation, or when an equation for a function is known, like unknown functions itself is unknown. So most of the time these are used as in calculus differential equations. So now because undefined functions and defined functions, each the one has a specific implementations and it can be numerically evaluated for all valid input parameters. So it is possible to define this type of functions. So Sympy dot functions. Another you can also use some cases look like some mathematical functions. It provide like Sympy dot naturally. Sympy has a built-in functions for the many standard mathematical functions that are available in a global Sympy namespace. So Sympy dot functions dot elementary, Sympy dot functions combinationals, and Sympy functions dot special. So in a sub package for comprehensive list of numerous functions that are available using a Python and the functions. Look here. So let's see, just I am going to use some trigonometric look like a Sympy dot sign with our important conventions. So if I write here the Sympy dot sign, Sympy dot sign, and because Sympy dot sign is a look like a sign, Sympy dot sign. Similarly, Sympy dot functions elementary, because this is a trigonometric signs. Sympy, if I write here Sympy like a dot sin x, sin and parenthesis x, Sympy dot sin x. So we can easily create here the sin x, Sympy dot sin x. And similarly, if I write here the Sympy dot sin pi multiplied with the 1.5, 2.5, 3.5, so you can easily get a value. So Sympy dot sign, and now pi will multiply anything, just 1.5 here, so you can easily get here exact value, because most of the time we know that sine 30, 45, 60, 90, 180, 360, 270 right here, but here we can easily get a multiple of this pi, 1.5, 1.25, and these things also. So when I apply it to abstract symbols such as a x, the sign functions remains unevaluated. So but when possible and it is evaluated to a numerical value, for examples just I have already applied here. So the numbers and the some cases it is look like integers also. So let's see just how do I write here. If I am going to write here n as a variable, and now the Sympy dot symbol because I am using the single symbol symbol as a capital S, and now n as string and integer 2. So in z will equal to true, right? So see here, just I am going to print here n. So n has been printed and look like this name here. Okay, what is this? I think I didn't write a name. Do not need a name here, so I am just going to print here n only. So n has been printed like this. Okay, so if I write here same way, I can write here look like a Sympy sin pi and n, Sympy dot sin pi and n. Okay, so it has been look like this, means Sympy dot sin and pi has been created look like this way. So I hope this will be, yeah, you can easily get a value whenever the multiplied with the pi through the n. So the third type of functions in Sympy is lambda functions. So let's see just how do I write a lambda functions. So just I am going to create here the lambda functions. So n as a variable and Sympy dot lambda. So L A M B D A and parenthesis x comma x square. So just I am writing as a functions look like x comma and x square in the sense this way. So look like here this has been okay, look like this. Actually sometimes some mathematical equations or expressions as a functions, if your internet is not working properly, so then this functions is not printed easily. So I hope, let's see, just I am using here the n and it may work because let's see, I think it has been printed in the few seconds. Okay, and similarly if you write the x and x tends to x square, another you can write here, you can put here the any other value. So let's see, just I am going to print here So print n. So is it possible to has been printed look like this. So n, I am going to print here n look like this. N has been printed, and I try to write here. Yeah, it has been printed look like x tends to x square. So same, if I write here the n 5, so you can easily get look like a value 10 and 6. So let's see what is the output if I am going to put, because I have already created lambda functions. So if I put here 6, and then we can get x tends to x square, so you can write here 36. Similarly, just I am going to write here h tends to look like a x look like n and 1 plus bracket start 1 plus x. Okay, so n at 1 plus x, and also so you can easily get 1 plus x, 1 plus x, it has been printed 1 plus x, x plus 1 whole square. Now the expressions, so the various symbols introduced in a previous section are the functions building blocks required to express mathematical expression. So mathematical expressions are represented as a tree, look like a tree means branches. Okay, so where leaves are symbols and nodes are a class instead that represent a mathematical equation. So examples of these classes are add, multiply and power for the basic arithmetic operations, and some product, integrals and derivatives for the analytical mathematical operations. So in addition, there are the many other classes for mathematical operations, and now we try to explain. So let's see, just I am going to here x as a variable. So first I write here, I am going to describe here expression expressions. So expressions, just I am going to write here x will equal to Sympy p dot symbol and parenthesis and x as a string. Now I am writing here expr as an expression. So right here expr will equal to 1 and plus 2 and x square 2 into x, and now write here double square and cubic equation. So you need to write here the plus and 3 times of x cube. Okay, so x and double star and cube. So let's see what has been printed, these expressions. So expressions look like a expr. Okay, so it has been printed look like this. So I hope these expressions can easily understand, and expressions is an instance to add with the sub expressions. So 1 2x square and 3x cube. and the entire expressions tree for expressions is a visualized. So note that we do not need to the explicitly construct the expression tree, since it is automatically built up for the expressions with the symbols and operators. So visualize these expressions as a way we will see after some time how it is a visualized like a three types of. So Sympy it works, it is important to know the how expressions are expressed. And now the if I need to get something look like a if I am using look like a ARGS attributes, so transport arguments look like and otherwise you can also express the. So let's see the ARGS attributes is and the empty tuple look like a tuples, which is okay. Let's see, just I try to expression. So AXPR dot if I write ARGS. So let's see what happens. Expressions, and I need to write only. So is it possible to write here the each arguments? Yeah, it has been created look like a. If I write here, I am going to put here expressions. I need to the put what is the first expressions. Okay, so AXPR dot ARGS and need to put here a square brackets, and I am going to put here 1. So let's see, 1 has been seen like your second means I think 2x square, because in Python it will start from the 0. So is it possible to get output like a 2x square? So arguments we can, so I think yeah, right. So this is a way we can easily express. Next way is the manipulating expressions. So manipulating expressions tree is a one of the main job for a Sympy, and numerous functions are provided for a different type of transformation. So just I try to, because tree can be transformed between the mathematically equivalent form and using a simplifications and rewrite of functions. And generally we do not change the expression and that are the passed to the functions, but we try to create a new expression. So now the simplification, first I am going to try here the simplification. If I write here expr as a variable will equal to twice will multiplied, and I am using x square, okay, minus x, now minus x, and another after parenthesis I am going to write here and again x, and then x will multiplied with x plus 1, x plus 1. So here we can see, and here I am going to write here 2 will multiply x square and minus 1. So let's see what type of expressions have been seen. expr, so we need to print expr, then we can get output is, let's see, expr. So minus x has been given, so x square, so it will multiplied with a 2x square, and yeah, it has been created, look like this is a way to write any expression. Yeah, 2x square, so we can easily write here the 2x square minus x, and again x plus 1 and minus 2x, okay, minus x and x plus 1 has been printed, and minus 2x, this multiplied with the yeah. So it's great. So similarly you can also the simplify here. So let's see, because we need to because whenever the multiplied with the x times x means it is a x square, so it is a like term, 2x square and minus x square. So now I want to simplify here. So simpy dot simplify, 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 and I am simplifying here expr. So expr, okay. So see here, simplify, yeah, it has been simplified there. So I think it is possible to the simplify. So let the simpy dot simplify expr, and expr dot simplify returns with the new expressions. Okay, if you write the expr dot simplify, you can return the new expressions. Yeah, look here, it has been the simplify. So look here, x square, and then it will be the x minus x, so minus 3x, so you can take as a common. So very good expressions, so you can write here. But some mathematicians, we can also write here the some trigonometric functions. So I try to express here expanding the product, cancelling a term, okay, factorizing expressions. So generally simpy dot simplify will attempt a variety of different strategy. So my aim is just you can write easily very well, because only few software can write here, but here you can write, and you can also solve through a Python. So why the Python is important? For if you are study BSc Mathematics, MSc Mathematics. So let's say expr and will equal to twice will multiplied with a something like a simpy ympy dot cos and bracket x, and this will multiplied with a simpy dot sine and x, and I want to print here expr. So let's see, is it possible? And this is the easiest way. If it means within a seconds you can create this type of expressions. So latex used, but you need to learn something different. But here you don't you can write in the easiest way. So this one has been created here. So simplify, we can also means your formula, if you write the 2 sin x cos x and then you can simplify here, it has been automatically can take a sin 2x, don't worry. So this is a way to you can easily. So simpy dot simplify means attempt a various method and approach to obtain a simpler form to a given expression. If I write the simpy dot trig simp, it attempt to the simply an expression using a trigonometric identity. If you write here simpy dot power imp, attempt to simplify an expression using the laws of powers. Simply simpy dot comp simp means simplify a combinational expressions, and if you write the simpy dot ratsimp, so simplify a expression by writing a common denominator. Another way, just expand it. So also we can use as a expansions, something like if you want to like expand something, okay. So log, also log true for expanding a logarithms. So it is also important for everyone. And now the factor, collects and combinations is also important. So I try to the expand. So let's see, expand. So expand means it provides the simpy dot simplify, so does not produce the satisfied result, then it is possible to make a progress by the manually and guiding it. So simply use a more specific algebraic operation. So let's see, simpy dot expand, perform a variety of expression. Simpy dot expand. So first I am write here expr as a expression, as a variable, and I am write a simple equation x plus 1 and another is multiplied with the x plus 2. So if it is multiplied with the x plus 2, right. So this expressions, and now expr has been created. So simpy dot, if I use simpy dot expand, so it will multiply easily. Simpy dot expand, so it has been created, look like this. But now I want to write here simpy dot expand expr. So let's see, it has been okay, just I think is why it is simply, I have gotten expand. I think I have already used this function. Okay, so it has look like it has been multiplied very simple way. So simpy dot sin x plus y dot expand, also if you want to write here as a trig will equal to true, so it is possible to print. So let's see, simpy dot sin and bracket start x plus y, sin x plus y and dot expand trig will equal to true. So see here, so because sin x plus y has been expand, sin a plus b will equal to sin a cos b and plus cos a sin b, look like this. Yeah, it has been pre means, So amazing. Now I try to look like a log. So let's try here. I write here a as a variable, another b as a variable, will equal to unpack. Okay, so simply sympy dot symbol symbols. Okay, and now bracket start a comma b, this one, and this positive will equal to true. Positive will equal to true. Right. Now Sympy dot log Sympy dot log and a b dot expand dot expand and log will equal to true. Log will equal to true. So let's see what happened. Just it has been printed look like this. I think sympy.log it is working look like this. So 1 minute, yeah, it has been printed. Similarly, I can also write here exponential form. So I write here exponential form like this. Exponential form. So Sympy dot exp like a exponential. So Sympy dot exp bracket start and I look like a integer way, just I, and will multiplied with a plus b bracket close, and now dot expand log will equal to dot expand and complex will equal to 2. Complex will equal to 2. So if you look here, just I am going to write here. So it has been look like I e to the power b sin a plus e to the power b cos a. So we can easily create the expand also if you want to expand and you write the. So calling the Sympy dot expand functions with these keyword argument set to true and equivalent to calling a more specific functions. So these are the very simple and basic way we can write the mathematical equations and we can also solve. So next time I will try to solve like a factor, collect and combine the expression, and now apart together and cancel of the sum expression, substitutions, okay, and under numericals evaluations, and then we can enter as a calculus. Thank you.